Hi, my name is Tanner Beck, and in my group is Philip Spratling, Carl Karsh, and Sarah Wilder, and we decided to tackle the Eaton Supercharger lift assist problem. So in this hypothetical problem, the Athens-based Eaton manufacturing facility requires a lift assist apparatus that consists of a bridge and the actual lift assist mechanism. And what we're doing in this problem is we're trying to choose one of each from a line of Gorbel bridges and Gorbel G-force lifts that will maximize efficiency and will minimize cost. So we're working with a few assumptions here. Number one, that the lift assist mechanisms are always at full load capacity, i.e. the 178 pound is always carrying a load of 50 pounds. We are assuming that the weight of lift assist is included in the capacity, so we're using tare weight here, and we are assuming the acceleration is going to be a average that we're getting from the maximum velocity and the maximum height. So from our original interpretation of the problem, our goal was to design a custom assembly that would minimize initial cost and long-term operating costs while maximizing safety and manufacturing efficiency. And this changed a little bit as we realized that we would eventually have to settle on a prefab Gorbel assembly anyway. And so we modified our goal to use the cheapest lift assist model possible that would be both functional and safe. And so we went ahead and looked at the different capacity options for the lift assists, the Q series. And just from static load, we decided that the 330 pound model would be just fine for our purposes, and then we used that model to calculate our acceleration based on the lift assist's maximum velocity and the lift assist's maximum range. So from this average acceleration that we calculated, we found the summation of the static and dynamic forces. This means that not just gravitational acceleration, including the acceleration of the lift assist actually moving upwards. And with this calculation, we got a value for the total force, which on the maximum, so the 178 pound end effector, that would only produce a force of 228.5 pounds on the bridge. And so based on this, our 330 pound capacity end effector will still be sufficient for the problem. So after we had the model of the end effector nailed down, we went ahead and tried to look at the bridge load. And so listed on the screen are the maximum capacities for the different models of the Gorbel bridges. So our maximum force is 228.5 pounds, including the static and dynamic forces. And so we thought that although the 250 pound bridge would be sufficient, if anything went wrong, it would be easy for that to go above max load. And so we felt, just for safety, that we would go with the 500 pound Gorbel bridge. So yeah, at the end, based on our assumptions and calculations, we decided that the 330 pound capacity lift assist and the 500 pound capacity Gorbel freestanding bridge are safe and cost-effective solutions to the problem.